Alright, we are in Algebra 2, Chapter 2, Section 2, Linear Inequalities. First, let's talk about the number lines that we have here. One thing we need to understand is that if we go to the right, we're going into the positive direction, and this number line goes to positive infinity. If we're going to the left, we're going negative, and it goes to negative infinity. So those number lines continue to go on even though we don't show it. We only draw number lines so long, but they do continue to go. Alright, when we talk about inequalities, you'll see over here I have the inequality of x is greater than 3. We can represent that numerous ways. We can show it just like we've got it here. We can show it on a number line. Couple other ways we can. What makes it an inequality is that you're not going to get one solution. There's going to be a lot of different numbers that could apply. For example, if x is greater than 3, x could be 4, x could be 5, x could be 1,000, x could be 3.1. So there's a lot of different things that it could be. What we do know is it's not 3 because it's greater than 3, and it's not less than 3. So the way that we would represent this on the number line is at the 3, we're going to put an open circle. So instead of a dot, we're going to put an open circle. The open part tells me that it doesn't include 3. If it was a solid dot, it would say it does. And then we're going to go from that open circle and represent everything that it could be, which is everything to the right, all the way to positive infinity. So I'm just going to mark that to the right so I can clearly show which way it's going. The next one we have x is less than or equal to negative 2. That or equal to changes it. That means it could be negative 2 and everything's smaller. Well, if we go to the right on a number line, we're getting larger. Therefore, if we go to the left, we're getting smaller. So my starting point is at negative 2, but instead of, I'm not just going to leave an open circle like that because it says or equal to. I'm going to fill in and make that a dot. Then I need to represent everything smaller than negative 2, so I'm going to mark it to the left and fill it in there. The last one I have on here is negative 5 is less than or equal to x. And x is less than 4. So the first two that I did, these are intervals. The one I've marked is the intervals that x can be included in. They can be bounded or unbounded. The first two examples are unbounded because they go continuously in one direction or the other, or even both. In the one that we're about to do, it's going to be considered a bounded one because x is wedged in between two numbers. So we're going to have a starting point and an ending point. My starting point is going to be my first number, negative 5. So I'm going to go to negative 5 on the number line. I'm going to make my circle, and then I'm going to, do I fill that in or do I leave it open? Well, because it's or equal to, I fill it in. Or equal to is solid. My other end is at positive 4. So that one is not or equal to. So that one is going to be an open circle. So this is called a bounded interval because x is somewhere between those two endpoints. Alright? So unbounded is the first one. Unbounded is the second. And the third is bounded. Now the last thing we could do is we could double check these. And the way we're going to do that is we're just going to take a value that's inside of our deal. So we see 5 here, right here. 5 is in the red. So I'm just going to pick 5 and plug it into my inequality. So 5 is greater than 3. Is that true? Yes. That means that this one is correct. On my second one, I'll pick, let's just pick right here, which would be negative 4 negative 5. So negative 5 is less than or equal to negative 2. That is also true. And lastly, let's just pick 0. Go back, and negative 5 is less than or equal to 0, which is less than 4. That is also true. So all three of these we're done with, and we've checked to be accurate. Okay, so there's several different ways we can present a inequality. We've seen two ways. We've seen the first way is called inequality notation. So that's just going to be I can't spell today. That's just going to be the x is less than or greater than 3 that I have written here. X is less than or equal to negative 2, and negative 5 is less than or equal to x, which is less than 4. The second one we have is a number line representation. Alright, the last one we're going to talk about is interval notation. Alright, so on interval notation, on x is greater than 3, what that means is that I would start at the 3 and it would go all the way to infinity. Alright, similarly to on this one I used an open circle because it didn't include 3. On this one I'm going to use parentheses on the bounded end. Alright, so the unbounded end where it goes to infinity is going to be parentheses. The bounded end is going to be parentheses. On the next one, if x is less than or equal to negative 2, that means that my range goes from negative infinity to negative 2. And this one can include 2, so instead of a parenthesis, I'm going to use a bracket. Alright, so when I look at the inequality notation, I see x is less than or equal to negative 2. When I look at the number line representation, I see that x is less than or equal to negative 2. And when I look at the interval notation, I see that it includes any number that goes from negative infinity all the way up to and including negative 2. Alright, and on this last one, on the bounded one, we always go from left to right. You'll notice I started at 3 and I went to positive infinity. I see that it goes from negative infinity to negative 2. We always go from left to right. So my starting point is negative 5 and it includes negative 5, so I'm doing a bracket. The other end is at 4 and it doesn't include, so I'm doing parentheses. Okay, so when solving linear inequalities, we have two rules. We have an addition property of inequality, which is pretty much the same as the addition property of equality. Basically, if A is greater than B, then A plus C is greater than B, and A minus C is greater than B minus C. So basically all that means, let me add something here. A plus C is greater than B plus C. Alright. Basically all that means is that if I add or subtract anything to both sides of an inequality, then the inequality is still true. For example, if I have 4 is greater than 1, if I add 3 to 4 and I add 3 to 1, I get 7 is still greater than 4. Alright? Same thing if I had subtracted. If I had 4 is greater than 1 and I take 2 away from both sides, then I get 2 is greater than -1. Still true. Alright, so nothing really new there, except for it works with inequalities just like it worked with equalities. The next one, the multiplication property of inequality, states that if A is less than B and C is greater than 0, then A times C is still less than B times C, and A divided by C is less than B divided by C. So again, that's just a fancy algebraic way of saying that if I multiply or divide both sides by a positive number, then the result is still true. So an example of that would be if I have 2 is less than 4. Then if I multiply both sides by 2, then I get 4 is less than 8. Okay, still true. If I had 2 is less than 4, and I divide both sides by 2, I get 1 is less than 2. Still true. Alright, so I can multiply or divide both sides by a positive number and have the same result. But I've got to note that when I'm multiplying or dividing by a negative, then I'm going to have to reverse my inequality symbol. So we'll look at an example of why. If I had 2 is less than 4, and I multiply both sides by -2, then I would get -2 times 2 is -4, and on the other side I would get 4 times -2 is -8. We need to notice that -8 is smaller than -4 because it's further to the left on the number line. So I've got to reverse. Notice my inequality had to change directions. Originally I said 2 is less than 4, but when I multiplied both sides by negative, it became greater than. -4 is greater than -8. With these types of problems, that's probably the most common mistake we make, is we feel like we're doing well, we're solving these inequalities, we're moving numbers from one side to the other, but we forgot that we multiplied or divided by a negative number, and we forgot to change or reverse our inequality symbol. Okay, so let's talk about the steps to solving a linear inequality in one variable. The first step is I'm going to simplify both sides of the inequality using the order of operations. Second step is I'm going to isolate the variable term. I'm going to be using the addition property of inequality to do that. Number 3, I'm going to isolate the variable, not just the term the variable is in, but the variable itself. To do that, I'm going to have to use the multiplication property of inequality. I'm going to graph the critical numbers on a number line. Okay, the critical numbers are just the number. For example, earlier we did x is greater than 3, I believe. 3 would have been the critical number on that one. If it's a bounded term, it'll have 2 critical numbers, both ends of the graph. I'm going to pick a value within my solved inequality to see which side I need to highlight, and then I'll graph the entire inequality. So let's walk through that. I've got the inequality of 3x plus 2 is greater than 5. So I'm going to simplify both sides. There's no like terms. There's nothing I can do there. So I'm going to isolate the variable term. The variable term in this one is going to be 3x. So 3x is the term that has the variable in it. I'm going to try to isolate it. I'm going to do that by using the addition property of inequality. So I want to move this 2 to the other side. It's being added. I need to subtract that from both sides. That addition property of inequality says I can do that, and it still remains true. So I'm going to scratch those out. And that leaves me with 3x is greater than 3. Next step is I'm going to use I want to isolate the variable. So now I've got 3x. I don't care what 3x is greater than or less than. I want to know what x is greater than or less than. The way I'm going to do that is use the multiplication property of inequality, because I need to divide both sides by that coefficient of 3. So I will divide this side by 3, and I will divide this side by 3. That's a positive number. they're going to cancel out. And because it's positive, I don't have to worry about reversing my inequality sign. So I get x is greater than 1. So that was step 3. Step 4 is graph the critical numbers on a number line. So I'm going to draw me a not very straight number line over here. 0, 1. I know that's my critical number is 1. It's greater than, it doesn't include it, so it's going to be an open circle. And I need to pick a test value. So let's just say, let's pick 2. 2 is greater than 1. Pick 2 is greater than 1. That is true. So 2 needs to be included in my graph. 2 is to the right, so I need to graph it going to positive infinity. So x could be any number from 1.000001 all the way up to positive infinity. Alright, so let's look at one like, let's do 4x, not x, let's just do 4 minus 5x is greater than or equal to 24. Alright, first step, simplify both sides. I'm done, nothing I can do. Second step, isolate variable time using addition property. So in other words, get rid of this constant. Subtract 4 from both sides. I get cancellation there. Negative 5x is greater than or equal to 20. Now I need to get rid of that negative 5. So I'm going to divide both sides by negative 5. And I'm going to get negative 5 and negative 5 cancel out. Leave me with x. This is where you got to remember, I've multiplied by or divided by a negative. I need to flip that inequality symbol to less than or equal to. 20 divided by negative 5 is negative 4. I'll pick me a test point. Let's just say, let's pick the test point 2. So my test point is 2 less than or equal to negative 4. Get my number line over here. Yeah, 0, 1, 2, 3, 4. So that's negative 4 is my starting point, my critical number. It is solid because it's or equal to. So now I just got to decide, do I graph to the left or to the right of that? So when I look back at my test point, 2 less than or equal to negative 4, that's not true. Which means 2 is not going to be included. Well, 2 is way over here. I want to make sure that I go the direction that does not include it since it wasn't true, which means I'm going to go to the left. Alright, so we got to remember to flip that inequality sign, and then the test point, if it does make the inequality true, then it needs to be included in the side that you graph. If it's not true, then it does not need to be included in the side you graph. Alright, let's look at one more. Let's look at one that's bounded. So I have 20 is less than 10x, which is less than 30. I'm going to go ahead and solve for x on the inequality. So I need to divide all 3 of them. So I'm going to divide the x term, the variable term, by 10. I'm going to multiply the 30 by 10, and I'm going to divide the 20 by 10. So I'm going to get 20 divided by 10 is 2, is less than, those cancel, leaving me with just x, which is less than 3. Alright, so I've got 2 is less than x, which is less than 3. So I'm going to draw a little table here. Let's see. I'm going to have my interval. I'm going to have my test point. And I'm going to have, is that a solution? Alright, I'm going to go ahead and graph my number line over here. Got 0, 1, 2, 3, 4. So my critical numbers are 2 and 3. Neither one of them are equal to, so they're going to be open circles. My intervals are going to be from negative infinity to 2, and then from 2 to 3, and then from 3 to positive infinity. Okay, so my critical numbers break this thing up into break the number line up into 3 different intervals. I know it cannot include 2, it cannot include 3. Alright, so I'm going to pick a test point inside each one of these intervals. If I go from negative infinity to positive 2, 0 is in that interval. From 2 to 3, let's pick 2.5, right in the middle. And then from 3 to infinity, we'll pick 4. So I'm going to test each one of those. If I plug in 0, I get 2 is less than 0, which is less than 3. That is not true. So no, it's not a solution. If I plug in 2.5, I get 2 is less than 2.5, which is less than 3. That is true. So yes, it is a solution. And then the last one, if I plug in 4, I'll have 2 is less than 4, that's true, which is less than 3, which is not true. So one side is, the other side is not. That is not true. Alright, so what that tells me is that 2.5 needs to be included in my interval when I graph it, but the other two don't. So 2.5 is going to be between these. The 4 on the outside does not need to be included. 0 does not need to be included, so that would be how I graph that inequality. Alright, last one. We pick one a little more complicated looking. I've got 12 is less than or equal to negative 4x plus 4, which is less than or equal to 48. So first step, simplify all 3 sides. Nothing I can do, everything's combined. Second step, isolate the variable term. The variable term is negative 4x, so I need to get rid of this plus 4. We're going to subtract it from all 3. So 12 minus 4 is 8, which is less than or equal to. That cancels. I get negative 4x, which is less than or equal to. 48 minus 4 is 44. Next step, I need to isolate the variable using the multiplication property of inequality, which means I need to divide both sides by negative 4. Alright, so because I'm divided by negative, I know that I'm going to have to flip my inequality signs. So I'm going to have greater than and greater than. And on the left side, 8 divided by negative 4 is negative 2, which is greater than or equal to x, which is greater than or equal to negative 11. So on my number line, I know I'm going to grab, this is my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's negative 11. Negative 2 is right here. That's my critical numbers. And because it's or equal to, they will be solid dots on each one of those. So now I'm going to pick a test point. I'm just going to be proactive and pick a test point that is between those two. I'm going to pick negative 5. So if I do negative 2 is greater than or equal to negative 5, which is greater than or equal to negative 11, is that true? Well, negative 11 is, here's my test point, negative 2, 3, 4, 5. Here's my test point. So yes, it is. Negative 2 is greater. It's greater than negative 11. So that one is true, works out, and I'm done. So that is everything that I have for you on linear inequalities. These just take some practice, and remember to flip those inequality signs when you multiply or divide by negative. You should do okay at this section.